Hello, everybody. This is the Read the Source podcast. We have Jeremy Danyow presenting the episode 12 of the Read the Source is Aurelia data binding. So we are very anxious. We waited this presentation for too long. So I think that we should get it started. Jeremy.
Hi, guys. Hi, I'm a software developer up in Vermont, and I'm on the Aurelia core team, and I work primarily on the data binding engine. So hopefully can show you guys some interesting things about how that works today. So you want to just jump right into the code?
Please.
Okay. So
let's not keep the audience waiting.
Okay, so let me share that. So this is the Atom editor, and these are all of the, well, almost all of the Aurelia repos that make up the Aurelia framework. And the binding engine is just one part of that. And I think the most logical place to jump in would be the property observers. So the way Aurelia data binding works is there's a property observer objects that know how to detect changes to particular object types. So for regular plain old JavaScript objects, for the most part, we have a class called the setter observer that knows how to detect changes to that object when something in the binding system needs to subscribe to changes. So the way that it does that is when subscribe is called, it converts the property. And what this means is it rewrites the property, the plain property, as a getter with a getter and a setter, so that way the binding system can detect when the setter is called and notify anything that's subscribing to property changes that a change has occurred. So back when object.observe was still a thing, we had an observer that used object.observe instead of property rewriting in browsers that supported that, but that standard, or that's no longer being pursued in TC39. So for the most part, all of plain JavaScript object observation occurs with a setter observer. In other situations, for example, in HTML elements, we have different kinds of observers that know how to listen for DOM events to detect when something changes. So I'm just going to scroll past some of these here, but this is the value attribute observer, which is used with input elements when something in the binding system needs to observe the element's value attribute changing. So what it does when subscribe is called is subscribe to that element's input and change events, and then when those events occur, we'll notify the binding system that's happened.
I have one question regarding this subscription mechanism. Is this does the subscription mechanism is a standard publish subscribe engine, or is it something custom that you build?
It's actually really custom. So if you were to look at the binding system just a few releases ago, you would have seen quite different code. So you can see that these methods take a context and a callable arguments. Normally, when you see subscribe methods, they usually take a callback argument, and that's the way the binding system used to work. So let me just go back, see so these observer objects I should have mentioned they all have a common signature. They have get value, set value, subscribe, and unsubscribe. And in the past, they had the subscribe took a callback parameter, which was a function. But in our performance tuning, we saw that creating those closures for the callbacks and maintaining arrays, like this observer would maintain an array of callbacks. That creates a lot of memory pressure, and we wanted to avoid that. So there's a pattern that is used throughout the binding system and in other areas of the framework where we have what's called callable objects. And those are objects with a very simple signature. They have a call method on them. And so we just pass the actual objects that need to be invoked around instead of creating closures and passing functions around. So this is, and I'll show you some more about that, but that's pretty much how subscriptions work in the binding system.
Okay, continue.
Okay, so we have observers for plain old JavaScript objects. We have observers for DOM elements. There's a few different kinds. And then we have a service that the binding system uses called the observer locator. And this service is used primarily to get observers for a particular object in property. So what'll happen is a binding instance, which I'll show you in a little bit, needs to observe a particular property, and it'll use the observer locator to get the appropriate observer for that object in property. So that's what the observer locator is for. It also has methods to get observers for collections such as arrays, maps, and soon sets. So where the rubber hits the road with all that stuff is in the binding expression and binding classes. So if you take a step back out of the binding engine, and because it's kind of hard to talk about the binding engine by itself without thinking about templating, the Aurelia templating engine, when it needs to bind an HTML template to a view model, because Aurelia's MVV, whatever you want, MVM, VVM, MVC, when it needs to bind those two things together, there's some steps that need to happen before that, and that involves looking at the HTML template, traversing the nodes inside of it, and making basically a list of the instructions to actually create a view instance. So we need to find all the binding expressions in the template and all the custom elements, custom attributes, whatever, so that when it becomes time to actually bind the template to a view model, we can do that. So the templating engine will compile the view and create a bunch of binding expressions, which you can think of as, or at least I think of as, sort of like the definition of the binding, not the binding itself, but just how, the instructions on how to create a binding when the time comes. So the binding expression has a few really important properties. Number one is the target property, which is the attribute of the DOM element on the DOM element that you want to bind to. So if this was a, if we were binding to an input element's value, the target property would be value. And then number two is the source expression, which is the actual binding expression, the way to access the value on the view model. And I'll cover how this expression gets built a bit later, but this is basically an abstract syntax tree that's optimized for the binding system. Number three is the binding mode. So Aurelia has a few different binding modes. There's OneTime, which means that the view model value is applied to the element once and only once. There's one way, which means that the view model value flows from the view model to the view, and when the view model changes, that'll be the view will be kept in sync. And then there's two-way, which means the data flows in both directions.
And I have a question regarding the one-time binding. What happens if at the expression evaluation, I don't know, step, the watched expression is undefined? Is that considered a one-time binding? Are we going to get an undefined and that's all?
So there won't be an error that will, the value undefined will be applied to whatever the element property is that you're binding to. So for example, if you're binding, if it would be as if you set the input element's value attribute to undefined programmatically, nothing's going to happen. It's just going to be empty string. The DOM will normalize, these kinds of things. Does that make sense?
Yeah. What I'm asking this is, let's think about the real case scenario when we are trying to get some data from a server and everything is done asynchronously.
Mm-hmm.
So we are getting the information later in time after the template is compiled, as you said, and the bindings were set. With this one-time binding, the data will be undefined at first until we have the data from the server.
I see. So yeah, there's a couple different options. Well, there's several different options for that. So your first option, which I think a lot of people do, is, and this is kind of outside of the scope of the binding engine itself, but there's a composition lifecycle that takes place whenever you're activating a particular screen or a view and a view model pair. And you can hook into that activation lifecycle and load your data during that lifecycle and sort of delay the actual binding until the data is present, and then you won't run into the issue you've mentioned. The other option would be to not use a one-time binding, instead use a one-way binding. And then there are ways to add behaviors to bindings. You can actually hook into the bindings lifecycle and force certain things to happen. These are called, this is a new feature that we added not too long ago called binding behaviors. So you can, one of the behaviors, for example, that just ships with Aurelia is that you can signal, you can give a particular binding instance a name and signal it when you want it to evaluate. You can, of course, create your own binding behaviors too if you had some more complex logic to implement.
Okay, so you can implement your own binding mechanism.
Yeah, you can basically apply additional logic to the existing binding mechanism, so you can intercept at different points in the bindings lifecycle, and also when changes occur to the target element or to the source data, you can hook in there and do very interesting things. But let's keep going through a binding expression and the binding system, and then we can look at some more of that stuff and some of the performance work that we are doing right now. So the binding expression, like I said, is just the definition of what the binding will be when it becomes time to create the binding. So you have the property that you want to bind to, the expression, the view model expression that you want to get the data from, and then we have the observer, locator, and lookup functions are resources that the binding will need when it needs to observe properties for changes. So with that binding expression, once that's created, when we actually instantiate a template, because we're getting ready to display it, create binding will be called, and the target will be passed in. And typically the target is an HTML element. So with that target, we'll create the binding instance. And let me just make this a little bigger. So when we create the binding instance, you can see that the observer locator that I showed before is immediately coming into play, and we're getting an observer that knows how to observe changes to the DOM element's property. So if this was an input element and this was a value attribute, the observer returned from this is the value attribute observer that knows to listen to change and input events and publish them when those occur. So the binding instance is created, and the next step that takes place, and I'm kind of skipping, like outside of the binding engine, the templating engine is orchestrating all of these steps, and that's a larger discussion for another read the source, I think. So I'm just going to try to focus on the binding aspect of it. So we have created the binding and pretty much hooked up to the DOM element, and now we're going to bind this element to the view model, which is represented by this source parameter. So this is where the two things pretty much meet, and the first block of code just deals with if this binding instance was already bound to a different object, then we need to unbind it and kind of reset the state of the binding. So that's all that is. And then the next two blocks of code have to do with advanced binding scenarios that I alluded to a little bit before. So I had mentioned that binding behaviors have access to a binding instance's lifecycle, and binding behaviors are something that you express in your template as part of the binding expressions. And so that's why we're checking this expression to see if it has a bind method, and if it does, we're going to call it, and that pretty much means that it is in fact a binding behavior, and that we need to give it an opportunity to do whatever it's going to do. So that's what that's doing. And here we have another, I guess we could call it sort of an edge case kind of thing. Some observers for DOM elements need to know about the binding lifecycle as well, because they have advanced behavior. One example of that is the input elements, or I'm sorry, the select elements value. It needs to hook into because it knows how to bind a HTML select element to arrays of objects and handle multi-select scenarios. So there's a bit more involved there than a simple input value. So that's why it has that callback. So once we get those edge cases out of the way, which for the most part, aren't used very much of the time, now we're into the real work of setting up the binding. So the very first step in the important work is actually pulling the value out of the view model. So we're asking the source expression, which I'll show you in a little bit how those are built, to evaluate against this view model, and then these lookup functions are passed in. That's resources for these allow the expression to access resources like value converters, or you may have heard them called filters, and binding behaviors, things like that. So we get back a value, and then we update the target element. So assign the value to the view. So now the views has the model value, and the remaining work is to set up the change tracking so that when the model changes, the view will become updated. So depending on the binding mode, if it's one-way or two-way, we need to do that work. If it was a one-time binding, this block of code would be skipped. But a one-way binding, we need to give the expression opportunity to set up observers, and likewise, if it's two-way, we need to subscribe in that direction as well. So that's how a binding is set up, and when a change occurs, here's that callable signature that I had mentioned before when we were talking about the property observers. When an observer detects a change, it's going to invoke this method and pass in the context that was used as when we subscribed, and depending on whether it's the model that changed, we will apply the model value to the view, if the value is indeed different, or if it was the element that changed, we will apply the element value to the model.
I have two questions.
Only two?
For this method.
Sure.
Actually, you have the first conditional is a conditional that the binding expression is not bound.
Mm-hmm.
When this can happen?
That's a great question. So there's a couple scenarios. When the binding systems, let me back out of this actually. So let me go back to the property observer and make that. So convert property. Just let me, right here. So let's say we are bound to a plain JavaScript object property, and you assign a different value to that property. Then we're going to publish that change event so that the binding system can react to it. But we don't publish it immediately. A task gets queued on a micro task queue to publish the fact that change occurred. And what this does, this is a very, very important piece of the binding system. By putting this change on the task queue, it in effect batches all changes and all updates to the DOM. It batches them together so that we don't thrash the DOM when you are changing things. So does that make sense? So because it's sort of the change publishing is async, there is a chance that the binding could have become unbound because you're closing a screen and opening another one, but in between there a change happened, and so we need to check to ensure that the binding is in fact still bound when the event is being handled here. Does that answer your question?
Yes.
And then to pile onto that, there is a set of enhancements. So here I mentioned that this was the most important work of the bind method. That's setting up or assigning the element. Assigning the model value to the view. That's most important in terms of getting the work done that's required to actually show the view on the screen. The rest of this work in terms of observation is definitely important, but can be deferred. And in the coming release of Aurelia, we're actually going to defer in certain situations, defer this work to to an animation frame to improve the time to initial render. So that's another piece of async work that we're throwing at this, where it could become time to bind something and it's in fact no longer bound. So anyway, that's why we have these checks.
Okay, and the second question that adds to another question is you are comparing at line 55, you are comparing the new value with the old value. So as far as I can see here, you are comparing only values. So if the watched expression would be an object that its reference will not be changed, this binding will not be triggered, right? Is it possible to observe objects as well?
So in this case, we're checking. I just want to make sure that it's clear what's going to happen here. We're binding a view model value to a DOM element's an attribute on a DOM element. So if it is in fact an object, it's not a. I guess I wouldn't say that's a very common scenario, but if it's a different object instance, yeah, the change would be detected and it would be applied. Maybe I'm not understanding the question.
Yep.
Let me just type a simple binding on the screen. So input value dot bind. This is kind of I should have put this up initially, but this is kind of the scenario that I've been talking about for the most part. So if we're here, what we're checking is the foo property's new value different than what it was before? And if foo is an object, then when that's assigned to the input's value, what'll happen is the DOM will stringify it, and the input will show like object or something like that. Did that answer?
Yeah, definitely. And another question.
Yeah, sure.
You're mentioning the fact that you are doing batch updates.
Mm-hmm.
Okay, so is there any chance that these batch updates can create inconsistencies in the rendered DOM? Like if we are watching to the same property value of an object in two different areas of the application. So are both DOM elements updated at once, or is there any chance that only one will be updated at the moment, and a later moment in time the second one will be updated? And if yes, is there any mechanism that will prevent this?
That's an interesting question. So what you're saying is we have, in one part of the app, we have a view that has this binding expression, and then maybe in a completely different view or a different component, we have another expression that ultimately binds to the same object. And when a change to this object is detected, will this lead to an inconsistent state? I'm having trouble thinking of a scenario where that would happen. The way the binding system works, since the work is batched, it'll happen in the order. So changes are handled in the order that they were published. So that's one, I think, reason to rule out that it could lead to inconsistency. And then the other thing is they will be published to subscribers in the order that they subscribed. So I think even if we took out the batching, things are going to happen in the same order for the most part.
Okay. Thank you.
Okay, so that is a binding in a nutshell. There are a few different types of bindings. So what we looked at was like an attribute binding, but we also have what are called interpolation bindings. So that's something like this, where you can just basically do ES6 string interpolation right in your templates, and these work quite pretty much the same way. So throughout this, we've been looking at the source expression and evaluating it and whatever. But so where does that come from? So when the templating engine encounters a binding expression, it's going to pass that expression on to the parser, and the parser's job is to take that string. So it might be something like foo.var.baz, 0 whatever, and turn that into an abstract syntax tree that can be consumed by bindings later on. So the first step is to look at the string input. Is it in the cache? If it is, return the cached abstract syntax tree. Those are stateless, so we don't have to, create a new tree every time we encounter the same binding expression. But if it's not in the cache, then the actual parser implementation is going to pass that string on to the lexer, which is going to tokenize the string. So split it up into a series of tokens, which can then be consumed by the parser and produce the expression, which is a bunch of these. So I'm just skipping through some of the more complex expressions. And so like one of your more simple binding expressions, like if you did something like bind foo, you're going to end up with an abstract syntax tree with one node that is an instance of access scope, and the name that it's accessing is foo. And when it evaluates, it's going to get the object that represents the view model and access that property name on the view model. And when we connect the binding, which was back here, when we're setting up the observers, this tree node knows how to, basically what part of the expression to observe, and it knows that it needs to get a property observer for this property name. Other more complex, the slightly more complex expressions. So if you did something like .bind equal foo.var, this would result in abstract syntax tree with that is an instance of access member, and access member's name, the member name that it's accessing is var, and the object is an instance of access scope, and it's accessing the foo. So that's how Aurelia's binding system connects to your source expressions that you write in your templates.
You can also have function executions as source expression.
Definitely. So there's call scope. Is a simple one. So that would be .bind. It's a lot like access scope. It has a name, so in this case it would be foo, but it also has a series of args, which themselves are expressions. Like so this knows how to, it's a bit more involved to connect one of those, because we have to observe the arguments, the expressions that are in the arguments for changes as well. So that is a lot of what's going on in the binding engine. We have quite a bit more time, so I was going to take you through some of how the binding engine has evolved to kind of reduce memory pressure and to improve performance in general.
That was my next question. How can we measure the performance of our applications, or is it possible to use this binding mechanism in order to reduce the calls, or I don't know?
No, that's great. Great question. So I actually don't have the code pulled down for this project, but we have another project called benchmarking, which I can just show you in the browser here. Let me just switch over to it. And there we go. So this is the Aurelia organization on GitHub. And there's a lot of different parts of the framework. And one kind of external part is our benchmarking project. And this has a series of benchmarks for different parts. So for example, binding.bind, this benchmark, it uses, I think it's called benchmark.js or whatever.
Sorry, can you please increase the size of the, thank you.
So this, back out of here. So these are all like the different benchmarks for different parts of the framework. So we have benchmarking parts of the binding engine, benchmarking dependency injection, the templating engine, and different scenarios in the binding and templating engine. So we use this quite a lot to prove that the changes that we're making are having an effect on the memory pressure. So the binding engine takes a look at the memory counters that are available in Chrome, as well as using benchmark.js to measure the actual time it takes to do a series of bindings, for example. And so that's what's going on here. So that's one way that we're measuring it. Another thing that we do is, I'll just show you some screenshots of this because it's part of the performance work that we're doing right now. So this, is we just use the debug tools that you probably use every day to measure the performance of different things. So let me just make this a little bit smaller. So what you're looking at here is the CPU snapshot of what happens when we were binding a very, very large table. I think it had 100,000 cells and, or I'm sorry, 20,000 cells and 100,000 binding instances. So something, crazy that you wouldn't really want to do in an app, but
yeah, definitely
just to see where, what was taking up the time. And so what we saw was, things that are happening as part of connecting the binding, like as part of setting up the subscriptions, are getting in the way of that initial render. And so what can we do to reduce that? And the first thing was the kind of the low-hanging fruit there was we don't need to create individual property observer instances for DOM elements that are used in one-way bindings. Those can be stateless, and we should just use static objects in that case. So there'd only be a handful of them for the entire app instead of one per DOM element property that we're binding to. So this is kind of before and after. You can the time up here is idle time. So even though you see the time is larger in the next one, that's idle time. It just means that I didn't click the mouse as fast, kind of thing. But you can see that it had the effect, of decreasing the amount of time spent hooking those things up by using static objects for this. And it also had a big effect on memory. So, sorry, I'm zooming around on you here. But before, we're looking at so objects allocated after rendering that huge grid. There's quite a lot here. A lot of setter observers, value attribute observers, because I had a variety of bindings in this test just to see what would happen. And then over here, you can see it's drastically reduced by making that change. So that's what's one change that's coming up in the next release that'll hopefully make your apps faster on initial render.
So we are going to have a performant application out of the box with the next release, right?
Yeah, I mean, we've already shown that it's very, very fast with things like, let's see if I can, BB Monster, for example. it's blazing fast on DB Monster. There's no, you know, there's no question that it really is fast, but we're always looking for ways to reduce memory pressure, make us better on mobile. You know, if you think back to when Aurelia was announced back in January, it was pretty much feature complete. There wasn't, you know, it was a fully functional framework, but in between now and then, we're just spending time, you know, fine tuning the performance aspects and adding, you know, smaller features here and there. So this is another kind of enhancement that for performance that we're working on right now. So I'd shown that we were kind of reducing the object allocations with static observers for the DOM elements. And from there, we still notice that there's some work. So again, this all represents work that's getting in the way of actually putting your view on the screen with the data bound to it. There was some stuff that we could defer until later, so that those are identified in red. So another piece of this pull request is to defer the work of connecting the bindings to the model and until later on, until after your view is rendered, so that you can, you know, this was just to show that this was in fact, you know, improving the performance.
Okay, I have one question regarding the binding. Is it possible to create programmatic bindings like in JavaScript and to have a function that will be executed whenever, I don't know, something is changed, a property of an object?
Yes. So let me switch back to the source code.
And if yes, I have another question. Who is responsible for doing the unbind, for executing the unbind? And this is I don't know, performance issue, or should I say a memory leak issue, that if the developer is responsible for doing this, is it possible to introduce memory leaks, like have orphan bindings?
Yeah, absolutely. If you as a developer are doing any kind of subscribing in pretty much any programming language and you do not unsubscribe, you are probably going to create a memory leak. For the most part, or at almost 99% of the time, unless you're creating bindings the way I'm about to show you, the templating engine is going to take care of subscribing and unsubscribing when appropriate for you, and you won't need to worry about that. So what'll happen at a high level, what'll happen is you click on a link in your app, the router's gonna notice a hash change or whatever. If it's a navigation style app, it's going to decide what view and view model to activate, and if necessary, it's going to compile a view if it hasn't been compiled already. Then it will bind the view to the view model, and then if you navigate somewhere else, it's going to take care of unbinding at that point for you, so that you don't have these subscriptions hanging around.
Okay, and at one point you mentioned that whenever the framework is doing a binding, is also passing a context.
Mm-hmm.
What is the context about? What does the context holds?
Yeah, that's a great question, actually. So back here, here's where we're subscribing, and we're passing into the subscribe function the context and then the callable object. And all the context does, because a callable object is just an object with a signature with a method on it with the name call, it's conceivable that you will subscribe and use the same callable for multiple use cases. And to enable that, we need to give the subscribee a context so that you can pass the context back to the callable object. So the callable object can know, okay, why am I being called at this point? So here, we're subscribing with target context, and I think this is, or I know this is just a string. I'm not sure. Yeah, here, it's just a string. It could be anything, but it's just a string. And so we're subscribing, and then when the target element changes, it's going to call the call method and pass in that same value. And that just allows, in this case, the binding instance to identify whether we're dealing with a change in the element or the target or a change in the view model or the source. Does that make sense? So that's why you have this like check up here. If it's this context, otherwise is it this context?
Yeah.
So creating bindings programmatically. You can, so in earlier versions of Aurelia, if you wanted to observe a property for changes and use the same mechanisms that Aurelia uses internally, you would get an instance of this observer locator class and call get observer and subscribe and unsubscribe. With the newer releases, we have a new class that we exposed that has a bit friendlier API. It's called the binding engine, and you can use it to create binding expressions on the fly, or get an observer for a particular property and observe that for changes. Or if you want to observe an array or a map for changes, you can call, get collection observer. So if you do that and subscribe to a change, to changes, when you call the subscribe method, you're going to get back an object with a dispose function on it, and you're going to want to call that dispose function to release those references. Otherwise, you will have a memory leak, like you mentioned.
That's clear.
Okay, so that is the binding engine, the binding, the syntax parsing, the performance work that we're doing. I guess we can talk about so we've talked about how property observation works, but how does collection, how do we observe array mutation, for example? It works quite similar to the way property observation works, in that we rewrite, let me just jump out to the array observation here. When we rewrite the array instances mutation methods so that we can intercept when they are called and notify the binding system when those changes occur. So here is the observer that is created when you want to observe an array for changes. And let's see, it has this static factory method that takes in the task queue and the array that we want to observe, and rewrites all of its mutation methods: pop, push, shift, unshift, sort, and all that stuff. And when those methods are called, it applies them to the inner array, or itself basically, but then also queues up a change record that will be published on the task queue, and again handled by the binding system bash style. So it may not be obvious that what this bashing enables, but it really is a way to do DOM diffing without virtual DOM, without the overhead there, and a way to batch changes to the DOM, again with very little overhead.
Does this batch mechanism have any major performance impact?
So the batching system, does the task queue have a big performance overhead? It's pretty simple. All that it is an array of basically callables. So as things get pushed into the batch, objects are getting pushed into this task queue's queue, which is just an array. And what will happen is it will flush the queue periodically. Well, I guess as soon as something gets pushed into the empty queue, then the flush action will be in-queued, and it will process the items in the array. So really, it doesn't have much for overhead because no new objects are created as part of queuing up. I guess you could say with array changes here, this is an object that's created, right? So this would be some overhead of this array observer, is that it needs to create an object that describes the change that's happening and pushing it onto the queue. But for property observation, there is no objects that are created, so it's very, very lightweight.
This is clear.
So that's the
impressive.
Yeah, I found this code to be very, very approachable and clear as well. It's been fun to really learn from it. Rob put together a plan a while back, listing all the different performance changes that he wanted to make, and we've been executing on that, and it's been fun, and it's been a great learning experience to see how to really squeeze the most performance out of something like this, and to see really the real impact that closures and object allocations and arrays, stuff that you probably you don't think about as much when you're writing a lot of code. It's not something you have to worry about, but something like this in the binding, these are quite hot code paths, so you really have to, every time you do something like this, you have to really think, is there a better way to do it? Should I be doing this lazily? Does it need to be done right now? That kind of thing. So, I think that's pretty much it for what I wanted to cover for the binding engine. If we do have some more time, we can look at some of the other repositories that kind of fit in between the binding engine and the templating engine.
Only if you have the time. So we covered most of the things that we were interested about. So if you have the time, you can do it. Anyway, if anybody has a question, you can use our YouTube channel or our Twitter channel. So you can ask us any question. We will get back to Jeremy, or you can use whatever channel you need to ask any question.
Yeah, if anyone has any questions about Aurelia, just jump on our Gitter channel. Let me put it on the screen here. You can definitely get help there, or jump on Stack Overflow, and you can get help there as well.
Because I have seen some impressive work and code there, so this can be an inspiration for somebody. Yeah. So do you have anything else for us, or we can, I don't know.
I think that's a good stopping point. I mean, we really covered the binding engine, so it's a good spot to stop.
That was great. That was great. And if you have the time to come back and show us the templating engine, would be great. Oops. I think that's something went wrong. Okay, sorry. I think I've got offline for a moment, or I don't know what happened, but if everything is good, thank you very much, everybody. We had 17 live viewers.
Okay, great.
Great, and we're waiting for more views. Thank you, Jeremy. You were a great guest.
All right, thanks for having me on.
Looking forward for your next presentation.
Okay.
Bye.